Hi, good evening, ladies and gentlemen. I'm so happy to be with you today. My name is Hatem Oueslati. I'm the co-founder and CEO of IOTEROP. And inside this company, we actually have a dream and we work really hard to make it happen. Our goal is to provide the technology that will bring a common language to the next 40 billion IoT devices that will arise by 2020. And not only will make them interoperable, but also more secured and remotely manageable. So I'll put you through in these 15 minutes. I'll show you how we do this with standards and make it a reality. The Internet of Things is an historic opportunity for the industry, a revolution. Tomorrow, 40 billion devices will monitor and control our electricity and water consumption, the quality of the air we breathe, our traffic signs and lights, and soon in the near future, our connected cars. But today, the industry is facing three main roadblocks. A security defect into an IoT device can have serious consequences. We talk about potential energy blackouts, traffic light hacks, or even massive data hijacks. Today, deployed IoT solutions are mainly based on proprietary technologies. They are extremely fragmented. And such solutions just work in silos and are incompatible to each other. It's like giving a phone to 40 billion devices and then you realize that no one speaks the same language. How will we maintain and manage 40 billion devices once deployed on the field? Well, remote device management is key in order to control deployments, but also maintenance costs. So I'll give you a few numbers to illustrate those facts. Tomorrow, the industry in the next 4 years is going to invest more than $80 billion in buying device management technologies. So there's a huge opportunity ahead of us. Security defects in IoT can affect people in the real world. There have been some serious cases already, and I'll give you for example. A University of Michigan team demonstrated the ability to change traffic signals, alter logic commands, and also disable the signaling devices remotely. Another example with a widespread fraud that was discovered using smart meter hacks to underreport energy use. In that latter case, malicious employees offered to alter customers' energy meters for a fee, and this costed over $400 million to the utility company. A security firm demonstrated the ability to install malware onto commonly used smart meters in buildings. They could remotely cut power in buildings and demonstrated they could spread that attack on a larger scale. Another example in public transportation, where a teenager could successfully gain access to the tram system in Lodz, Poland. So here, he manipulated the signal controls, was able to change them, and make the tram derail that caused injuries to passengers. At IOTEROP, we work closely on deploying concrete IoT solutions for the smart city. Cities are indeed a perfect field of application for new and innovative services that the Internet of Things makes possible. But most importantly, IoT helps cities to reduce their energy bills because this is often one of the most important parts of their expenses. So IoT here is used to monitor, detect issues, alert, and take actions upon electricity, gas, and water consumptions with sensors disseminated into public buildings like administration, schools, gymnasiums, or sport fields. IoT also helps to ease citizen lives, alert them on environmental dangers like flooding, water or air pollution, advise them on their energy consumptions, inform them on traffic and transportation conditions. And I'll give you a concrete example that we are working on with a partner. Here, we reuse smart meters already put in place to report water consumption. And we change the frequency into which they report water consumption data from once a month to twice a day. And this transforms those devices into a new tool to help monitoring and maintaining isolated or edged people at home. So in that case, if a monitored person did not consume water for a day or two at all, his relatives can be alerted. Other examples where IoT can bring new services to private companies and citizens, optimizing their waste collection, securing public location, analyzing and optimizing traffic flows. Another concrete example that we are deploying in the smart city of Montpellier in France. So we work with a partner that is able to place sensors in the city to locate free parking slots, because you have to know that 30% of traffic in a city is due to people looking for a place. So that's another concrete example of how IoT can solve people's hurdles. Well, that is the vision, but the reality on the field is much different. Cities actually see a lot of different IoT players, mostly proposing proprietary solutions and services to enable those use cases. And such solutions, they can't be mutualized. Sensor manufacturers all report the data in a different way. Accessing and managing the sensors is done differently depending on the solution or the sensor vendor. And operating and maintaining such solution for cities incurs significant overcost for them. And cities, they don't want to be locked down on proprietary solutions. They invested or plan to invest a lot of money in deploying their infrastructure. So they remain it to be open and scalable. Well, I'll give you another concrete example for IoT device management in the industry, and in that case, in the car industry. So 2014, the US government asked Tesla and GM to recall certain model of cars because of a risk of fire coming from faulty spark plugs. So two different automakers actually concerned by the recall, and you see that two different ways to handle the same issue. On one side, Tesla embedded standardized and secure device management technology, and based on OMA, 29,000 cars are fixed remotely through a software upgrade. And GM at that time didn't have such technology in place. 380,000 cars need to go to dealerships for a manual fix. And as you can see, this is where IoT device management technologies can make a significant difference, of course, in terms of maintenance cost, but also in the user experience. So what is the overall solution? Standards. Standards are the keys to fix this fragmentation and make IoT solutions scalable and sustainable. And OMA Lightweight M2M is the most relevant standard created today to tackle those three issues at the same time: interoperability, security, and device management. It has been especially designed for constrained devices and works over a wide number of transports. So Lightweight M2M is often perceived as a device management only protocol, but actually this is much more than that. This is a fantastic tool to convey real interoperability between all the IoT elements in the value chain. It defines a powerful resource and data model. It promotes common data exchange formats. It also has device management and onboarding method. So it relies on CoAP, itself defined by the IETF. But using CoAP only is not sufficient. Lightweight M2M do provide the IoT service layers needed to develop interoperable IoT solutions, whereas CoAP is only a means to convey data exchanges. So if you prefer, CoAP is the binary equivalent to HTTP. So as a developer, for example, if you want to develop an internet browser application, you'll need the HTML language on top of HTTP in order to view your web pages seamlessly. Well, that is the same between Lightweight M2M and CoAP, so that to ensure interoperable IoT applications. As developers, you may know MQTT, which is used today for the deployment of IoT solutions. Well, as its creator, Andy Stephen Clark, is saying it right? MQTT is intended as a transport, not as a protocol, and as such, it doesn't solve the interoperability concerns. So there's no resource, nor data model, no common service definitions, and no device management capabilities. There's actually a lot of missing pieces that developers need to bring on top of it in order to build an IoT solution. So using MQTT only to convey data from sensors will just result in increasing the existing fragmentation. So what Lightweight M2M can change? And here is the situation today. If you want to develop an IoT solution operating with different sensors, you need to adapt your application according to each deployed sensor kinds or manufacturer. And this fragmentation incurs significant integration costs and maintenance hurdles for you, but also for your customers. And Lightweight M2M significantly eases the development of interoperable solutions. All your sensors can be reported using a unique and standardized format. You interact with all your sensors using a single API. You can, for example, change the data reporting policy dynamically. And this is exactly what we did to change the water consumption sensor into this new tool to help monitoring people at home. And this is only possible using a standardized method. So thanks to Lightweight M2M, you increase the relevance of reported data. You optimize the cost to transport them to your application. You get only what you need. And last but not least, you give the connected objects a common language to work together directly. Well, they can take action directly between sensors and actuators, and they can be overall more intelligent. With Lightweight M2M, the security is enforced at every level. So device authentication is used prior to a new sensor admission into the IoT network. Communication between all the IoT elements are secured as well. So exchanges are encrypted or ciphered using light but a powerful crypto algorithm. And all of this just prevents data interceptions, falsification, and hijacks. Well, just a word about who we are. So it's been 70 years that we're recognized for our ability to transform standards, which are just paper, into concrete and powerful technologies. So we are both involved into the Lightweight M2M standardization body, so inside the OMA, and inside the open source community as well, as we are the creators of Eclipse Wakayama project, and that to enforce our leadership on that technology. So if you want to integrate Lightweight M2M fast and easy in your solutions, well, our commercial SDK is really what you need. In literally 10 lines of code, you get it done, and you'll get the support of the best experts in the world. So come and talk to us now, and we'll building powerful IoT solutions based on standards together. So thank you for your attention. I just keep some time for question now.